This video is going to be about how humidity changes the partial pressure of oxygen as we breathe air in from the atmosphere into our lungs. In a previous video, I covered what partial pressure is. So I would encourage you to go watch that video first before you watch this one. This video is going to cover how does added humidity affect the partial pressure of oxygen. The first thing to talk about is the conducting zone versus the respiratory zone. The conducting zone, its primary function is to conduct air from the mouth into the lungs so that gas exchange can occur in the respiratory zone. Its secondary function is to humidify, add water, gas, warm up, and filter the air. The components of the conducting zone are the trachea, the bronchial tree, and the bronchioles. All of these components will add humidity to the air as it comes into the lungs. So if we start at the mouth, as air comes in through the trachea and splits into the bronchi and the bronchial tree, further down, when the air passageways become small, they're called bronchioles, until finally the air arrives at the air sacs called the alveoli, where gas exchange occurs. If we track PO2 at the mouth, it's going to be about 159. And as air comes in through the system, it's going to eventually reach a PO2 of 105. So the partial pressure of air decreases as the air moves from the mouth into the alveoli. So therefore, adding humidity decreases the PO2. So we're now going to talk about why this occurs. If we look at a container of gases, like our lungs, which have nitrogen, oxygen, and carbon dioxide, in a previous video I covered that the total pressure in an atmosphere, in the lungs, anywhere, is the sum of the pressures contributed from all the gases. So the sum of the partial pressure of each gas. So therefore, in this container here, the total pressure would be equal to the partial pressure of nitrogen plus the partial pressure of oxygen plus the partial pressure of carbon dioxide. If we added some water vapor into the mix, the total pressure would still be the same, 760 millimeters of mercury at sea level. But now, those pressures would be contributed from 4 gases: nitrogen, oxygen, carbon dioxide, and now water. So again, total pressure does not change, and the vaporized water molecule displaces other gases. So as water comes in, it's going to replace different gas molecules, so there'll be less of them. So here water is replacing nitrogen, oxygen, and carbon dioxide, so that the partial pressure of all these gases decreases. So the partial pressure of nitrogen goes down, the partial pressure of oxygen goes down, and the partial pressure of carbon dioxide goes down. I've summarized this in the chart here. So this is the effect of adding water vapor, humidity, on partial pressures of gases. So again, in dry atmospheric air, total pressure is equal to the partial pressures of all the gases contributing, nitrogen, oxygen, and carbon dioxide. So if we have a total pressure of 760 millimeters of mercury with absolutely no contribution from water vapor, the total pressure for other gases, oxygen, carbon dioxide, nitrogen, will be 760 millimeters of mercury. So we've already done this calculation in a previous video, and you can know that in atmospheric air at sea level, the PO2 is 159, PCO2 is about 0.3, and the partial pressure of nitrogen is 601. But we know that water molecules disperse gas molecules, and therefore there's going to be a decreased pressure for all 3 of these gases for a given volume of air. So for example, in the trachea, the atmospheric pressure is still going to be 760 millimeters of mercury, but we've added water. So the water vapor is going to contribute about 47 millimeters of mercury of pressure. So the leftover total pressure for the three other gases is now 713. So each of them will have a lower partial pressure. So for example, the partial pressure of oxygen in the trachea is 149 millimeters of mercury, less than it is at the mouth. As we go deeper into the conducting zone, more and more and more water is added to displace more gas molecules. So the partial pressure of all gases goes down. And you can see that here, that in the alveoli, by the time the air reaches it, the partial pressure of oxygen is 105.